Welcome to my channel Structural Design Hub. Today we are going to do a simple design in IdeaStatica. I hope everybody already know what's an IdeaStatica. It is the first and the best software solution available in the world currently to do a connection design. So when we launch IdeaStatica, this is the screen what we can see. So let's do a simple steel connection design. I click on steel, I click on connection, and depend on the system performance and the connection which is already present in the software, it might take time to load the initial project. Yeah, my project is loading. Okay, so here comes the page. So we go with a blank design. So I am choosing a blank project, and here I have multiple options on the design code. I can go with US, Europe, India. So here I go with the Europe code and I click on create project. I have the new project screen ready. So I have three main parties here. I have members, I have load effects, I have operations. So members, to add members like the column and the beam. Like for any connection, we have column and beam. So we use this member option to add it. Load effect to add the load for shear force or moment in Z, X, or Y directions, and operations to give the connections to the column and beam. That's how we ensure the connection what we have designed is strong enough. So let's go add the initial members to it. So I right click on the members, select a new. So here I currently my plan is to go with the role selection. I choose the I selection here, and I click on all, and HEB 300, HEB 300. Okay. So I have my column ready. So by default for the column, it should be the geometrical type should be in continuous, and also the pitch should be in 90 degree. Now it's a column. So now we have to add beam to it. I right click on the member again, add new member, and to edit that, I click on the plus button on the right corner, and I again choose the I selection here, and I click on all, and HEB 240. Click OK. So I have my beam. So it should be perpendicular towards the column. So what I do, the beam should be always in ended option. Yeah, so yeah, and also it should be the pitch should be in 0. So now it is against. So since it's an ended option, so the beam is currently against the column. Now I can see some extra portions here which is connected inside the column. So we have to remove that. That's when we use the operation. And I use the cut option here, and we can see that is removed. Now the beam is welded towards the column. Now we need to ensure our connection is strong enough. So I go to operation again. I add the stiffener, that is to strengthen the column. I have multiple options to keep the stiffener. I can keep it as a low, I can keep it as upper, I can keep it as central, however I want it to based on the design. Here I go with the both option, and I can also change the parameters for the width, length, it's up to us. So let's go again and add widener to it. That also ensures our connection is strong. So this is the default parameters for the widener. So I go and I have multiple shapes available. I can keep it in a rectangular shape, triangular, or chamfered. So currently my plan is to go with, in this design I go with triangular flange. So this is a flange what you can see over here. So the thickness is 0 currently. Let us go with 10. So we can see that is increased. And again, let's increase the width and the depth. The current width, I give it as 140, and the depth, let's give it as 600. So we can see the triangular with the flange, that shape has changed. Now we need to see, so my connection is ready. Now we need to apply some load and see if it is strong enough. So I go right click on the load, click on new load. Right. So I can see multiple options. I can see the options where I can apply the load. So if we have multiple options to calculate the load, currently I go with the EPS, that is for stress and the strain analysis. I go with VZ, it is to that is for the shear force. So I give minus 15, and for MG, that's for the moment in Z direction. Let me give it as 50. Now let's calculate and see if our calculations were right. This takes, I mean, sometime depends on the connection. If it's complex enough, it can also take 2 to 5 minutes to get the result. So I can see this is passed. My analysis, my planes and my wells, everything is passed. So I can also come to check and see the details of it, of the plates and the wells. Like I said, that also depends on the complexity of the connection. It takes some times and also depends on the system performance. I go to weld. Yeah, so I can expand and see the equations and all what is already used. Yeah, so like I said, it sometimes it might some time also to see the equation and the details. So once this is ready, once it's passed, we can go and export the connection report. That also takes time, depends on the system performance. And and while generating the report, we also have multiple options to take the connection. So in the plane view, or in the top view, or in a different elevation, or in 3D view also. We also have option to choose different bill of material. So however we want, we can get the report. So we can save that report and share it with the relevant parties. So that's about it. So next time we will meet again with a different connection. Thank you.